good sessions after that. If at all you want to ask any questions, probably we'll try to park it at the later stage because we are already running out of time. We lost almost 6 minutes now, so we'll go to these slides straight away. Thank you for the sponsors. About myself, I'm Dr. Subramani Paramasivam. I've done a PhD in information technology, and I'm also a Microsoft certified trainer and MCSE, working on these technologies for a pretty long time, since 97, 98, when I started training for people back home in India. And I regularly speak in SQL Weeks, SQL Saturdays, SQL Server Geek Summits, Microsoft Certified Trainer Summits, and a few other programs like Data Awareness Program and DGOps Data Day. And I'm certified, and you can follow me on these ones. And this is a simple slide to show the Data Awareness Program. This is about people we are trying to teach students and kind of non-IT things. So you can visit dataap.org just in case if you want to see when the next event is going to be there in London locally. Before we get going, I want to know who my audiences are. So I have simple questions here. Any one of you BI developers? 1, 2, 3, 4, 5, more of them, okay. And how many of you would put yourself, come on, DBA, DBDs, developers and administrators? Few. Any data scientists? 1, that's good. And how many of you ever played with program R? 1. If you're going to see the visualizations and the R modeling what we are seeing today, is there any expectations at your end that you're going to do it in near future? Are you expecting to do that? Okay, let's go in with the contents. How I'm going to divide this session is like I'm going to spend almost about 15 minutes in the slides, and SSRS 2016's killer features, whatever we have with 2016. So I'm going to spend about 15 minutes on that. I'm going to spend R models in R itself for about 25 minutes, and R models in SSRS for 20 minutes, and mobile reporting in your mobiles. So I want to give you a heads up. If you have Excel in your laptop, you can have that. I've got some workshop sessions where you can really see how things are working on. And also, if you have smartphones, you can try installing Power BI. I'll give you some access for you to see the reports what we are going to develop here. So you can have those too, but we're not going to do it straight away. We'll do it towards the end. Any one of you familiar with this screen? Hey, pretty old stuff, right? 2005. 2008, not major anything, but 2008, it's like you see back in history how it was, what we have worked in the past with the reporting services environment. And this is the major change what we had with 2008 R2. Do you see the changes in the browsers itself, like how the look and feel, what are the other options that you got? So when 2008 R2 was released, I was very, very happy saying that, wow, all our questions, all our problems have been answered. I feel the same way when we have this 2016, because the look and feel and everything, the features, the benefits, what we're going to use, everything has been changed as well. Again, 2012 is almost like 2008 R2, but 2016 looks like this. How many of you played with RS as of now? Few. So this is how the actual reporting service is going to look like. I'm going to show you a demo, how it's going to look like and how we're going to make some of them. As you can see, we have KPIs on the top, mobile reports, paginated reports, and this is the overall screen where you will be playing with. Compared to this looks so shiny and cold, right? So we'll see some demos on that one too. And before we go into the reporting services demo, these are the brand new features what we're going to see and have a quick look. We have branding option. What is a branding option? So the look and feel what you have seen here in this screen, you can change to a certain bit. We did do this in the past, but you have to do it manually. But whereas with this one now, with the new feature what we have, it is much more easier. If you know to program JSON with simple scripts, you can clearly make out, you can put your logos onto this just with one click of a button. Customized parameters. We had so much of problems in the past when having the parameters, they don't line up properly. So if you want to do it like, say, for example, country, then the state, then the city, then the particular local places, you can't order them. Sometimes it may be jumbling around, right? So with customized parameters, you can say which parameter to go first, which parameter to come to the next one. Then we have KPIs, mobile reports, paginated reports, Power BI integration, HTML5. When we say HTML5, it is like it works with all browsers, like including the Google Chromes. We used to have problems with Google Chrome in earlier versions, but now they're all fixed because they're all part of HTML5 now. And we can embed mobile and paginated reports to web applications. So whatever reports you're going to produce here, you can put that into your web applications directly. You can render to PowerPoint. This was a brand new option. So when you render to PowerPoint, the very big plus point is you don't have to do any more lining up or pagination or kind of doing the layouts within that one. I'll show you a demo on how the PowerPoint would look like. PDF instead of ActiveX printing. So those days we had problems of printing to the files, but now with this new feature, PDF without the ActiveX, it really works very well. So we'll jump into the demo and see how things would work. How many of you are excited to see the new reporting services? Most of them. Great. So that's my virtual machine. I hope everybody can see it. And let me go to reporting services. Great, good start. So what I had to do is go to services, SQL Server, reporting services. I'm using that with my Windows account. So sometimes I need to give a restart. Okay, just give refresh. There you go. Looks nice. I'm going to put that into a bit more full screen. Can you see? Yep. So this is how it looks in my local reporting services. What do we see here? So we have the same traditional folders, and you can see these two are hidden. So if I don't want to see any hidden objects, I can simply say show, uncheck it, uncheck the show hidden items. So here I have data sources, data sets, paginated reports and R models. These two are the folders. We also have the KPIs, two KPIs. You can see, like, instead of going and opening a report, waiting for it to render, all you can see is whether it is red or green or amber, and you can clearly distinguish how it is going on, how it's progressing. Here, what data I have is, like, I've got a live database from gov.uk, which means, like, I've taken data sets starting from 2009 until 2014 to see how many people had accidents, of which how many people died. And now what we are trying to do with this R modeling is, we are going to see how many people are going to die, predict, in 2015 and 16 based on the data set what we had from 2009 to 2014. So this is a real life data grabbed from gov.uk. In this, I am seeing deaths by year 2009 2004. You can see the trends there. It started more in 2009 and then going down and then up. Here, reason for deaths. I have distinguished whether the death is based on nature, like disaster things, raining or heavy wind or something like that, or is it due to human error? Okay, so that is a simple thing what we have seen there. Then we have some mobile reports, then paginated report. So before we start, let's see what branding option is. So that's the settings option, and then I go to site settings. Here I have option called branding. Basically, what you need to have for branding is, here I have a JSON file, and I have a logo. Logo is an optional, and also I have a metadata. So basically, how it looks in your scenario to see it, I'm just trying to open that in Notepad. So all we have is like name, multicolored, example, brand. Here I'm giving some primary colors, secondary colors, neutral, secondary for mouse over, on click, and these sort of options. They're all embedded here. Like if you're programming with CSS style sheets, so you have to use some sort of things like that. So this is a JSON script what we have, and I have a metadata. So this is an XML format. So this metadata is going to use this colors.json and the logo in PNG format. The names cannot be changed. Colors.json should be in the same name. If you change it, it won't work. But the great option is, at least it works now. You have to group them all together into a simple zip file. You're going to upload the zip file, not the files individually. The system is going to detect what is in the zip file and it will apply accordingly. So I'm choosing the zip file and say open. Ta-da, the colors are changed. I've got my logo. And if I try to browse through, you can see various other changes being done. When I go to browse, this is my home page. Home page color is changed. So just with JSON, with all your local scripts, local colors, according to your company policies and requirements, you can modify your reporting services very easily. If I want to get back to the original position, like the original things like branding, you can only upload one package at a time. So all I have to do is simply remove and say yes. It will revert to the original factory settings, right? So there's a brand new option with the branding options with just one zip file. Let me go to browse and KPIs. Let's try to play with by creating a new KPI. Here I have a icon called plus new, and then I have got to create folders, KPI, mobile report, paginated report, dataset, and data source. I'm going to click on KPI. Here, this is a simple screen where it says what the KPI should be. So I'm saying InsideSQL KPI. And I can give a manual formats, the numbers, and it changes here. You can see the preview, how it is going to be placed in the home page. Instead of that, I'm going to choose from my database. Here, I'm going to choose the data sets, what I have. So for example, here, I have dates, weather dates, dates with reason, total dates by year. So let me choose one. Come on, I can load. If that's a problem, then I'll go and choose something else. I created earlier and it worked, and that's what we see in our home page. It's loading for some time now. So basically what you would do is, by choosing the data set, you would then choose what column that you have to program in. So for that, what I will do is, I can click on this human error and I can go to the manage section, and this is what you can see here. So from dataset field, I've got reason for dates as reason. I have not set any goal. And here I can choose, if I have a status called -1, 0, 1 like that within my data set, then I would choose that as dataset field. And since I did not had any status, I can choose here saying -1 bad. The ultimate goal on the KPI is like, we are seeing how many have been dead so far, which means it is not a good thing, or it is not supposed to be in amber, it's bad, right? So I then program to say, always say -1. So people will see like, but how many numbers been dead last year or something like that. You can set your data sets like that. And here you can change the visualizations to a line, or to the steps, or to the colored radars. Then you also have an option called related content, where you can choose a mobile report to come up with when you open the KPI, and also you can have a custom URL. So for example, if I choose a mobile report, and here I have few mobile reports, I'm going to choose new mobile report and say OK and apply. Then I go to home. This is the one what I edited earlier. So I'm clicking on that. It says, because of human error from 2009 to 2014, this is the histogram that it's showing. Plus it also says this is the related content. So this is the mobile report what we have chosen earlier. When I click on that, it opens up the mobile report easily. So it's like one point of view where you can see what is there on it. So this report, we'll see what and how it looks like earlier. That's how you would create a KPI. Let's try and create a mobile report. For mobile report, we now have an application called SQL Server Mobile Report Publisher. You can always download it by clicking on this button. Here we will be dealing with 3 tools. One is Mobile Report Publisher, then the Report Manager itself, then we have the Report Builder. So with the report Builder, you would build a data set. Okay. With this Mobile Report Publisher, I can close this. Does this screen familiar to any one of you? Okay. Have anyone worked with DataZen product? Cool. So they have acquired from DataZen. So that's one of the very good mobile reporting tool. Here, these are the options that you have. For example, if I have to choose any one of these ones, if for example I am choosing pie chart, I can expand it however I want to. Then I have to choose a data for it. So I'm going to the data section. By default, it comes with a simulated table with some profit and sales. So you can ignore that. And you can go to add data. You have to choose your report server where you have stored your data set. I'm going to the data set, and in here I'm saying weather deaths. This is the outcome. So here basically find no high winds. When it is all weather is good and no high winds at all, then that is something supposed to be a human error. Apart from that, you can see raining, high winds, other, again raining, high winds, fog or mist, snowing, data missing. So I categorize them all into the other categories. But still, without them all, human error stands the most of them, 8,709 accidents. Now to apply this to the pie chart what we chosen earlier, you have to go here to the main series to say weather dates. So it's like Excel tabs what we have here. So you have to choose them here. Then go back to layout. It says 10.5K pounds. So it is settings what you have to do. By default, pie chart brings out in that way. Here it says the total dates is 10,488. And when you select the rows, you can see a different visualizations on it. Now I'm going to close this and open the existing one to show how a cool interactive report would look like. Let me go to full screen. In here, they have data for all year, last 6 months, last quarter. This is something happening. This was not possible earlier, definitely not with reporting services. But now with mobile reporting, things have been changed. It is 100% interactive reports for you. You choose something here, you see the values changing. So what happened during this period, and if I choose January, you see the whole of these options being changed. For June, you see the values are getting changed. So they are all like very, very interactive reports, and it really helps plenty of people to see. They don't have to go to Tableau or any other company's products. All you have to do is just integrate everything into one. Guess what? All of these reports, when you have a mobile report out, you can see them in your mobile. Android phones, iOS, wherever you have this Power BI app, you just install it. There you go. You can go for it. You can add it. So this is how a mobile report would look like. A paginated report. How many of you have heard about paginated reports? Yeah. So it's a regular reports what we build. But in terms of paginated reports itself, like with this, you can build some sort of pagination like header, footer. You will have categorized things. So if I show you in this example, this does not look no way to any difference to any other reports what we build with our day-to-day SSDT tools or with just normal SQL Server reporting services tool. So this one is simply a report that is built using a paginated thing with report builder option on it. You also have option with SSDT as well. While this report is loaded, okay. I also like to show you the print option. So this is what I was showing you earlier. You can choose the option of A3, A4, whatever size you have. These options, like initially you had ActiveX control, but now it's been totally replaced, which means like you have very good feature on how you want the report would look like. Then you have these shiny PowerPoint coming out, where if I choose that PowerPoint, it's asking to open or save. I'm saving it. I don't have PowerPoint in here, so I'm going to my local system and place it there. Open up the PowerPoint. So I had 2 charts in it, and 2 charts I've been going to your different slides. The thing with this, you can expand it, you can make modification to this. It does not render as an image. It helps you enable for you to make any changes you want to, even after exporting to PowerPoint. How many of you in your company are still exporting everything to the PowerPoint and they do manual PowerPoint reports? Finance mostly does. They have to present everything in the financial things based on the PowerPoint things. So obviously, what they need is PowerPoint integrated one. With this, that problem is totally solved. Okay, and if I go to new and paginated report, it is asking to get the report builder downloaded. I already have, so it shoots up. This is how it looks like with the new report builder option. Here I have two options, but one is not showing up here. What I do, I try to open up again. So report publisher. Okay. All right. So this is what I want to show you. So when you say new, you have option for new report and also for your new dataset. The dataset what you're going to create here will be visible for you to create your mobile report and also for your KPIs. Okay. So you can create here. So for example, I click on these particular ones. If YSM Lab 01 in these services, I say create. And here you have option to choose what are the tables we have, or you can simply type your T-SQL statements here. Let me close that. So in here, we have the same options like what we have with the earlier ones. But you also have the feature of building obviously new data sets, all paginated reports. This can be viewed in your SSDT. You can extract and render it in that one. And this is the place where you would build a small normal reports. The business users mostly use the report builder just because they don't have enough expertise on SSDT. It's a miniature version of the SSDT where it enables anyone to build a brand new report. Okay, did I miss anything else? At the very end, I will give you an option to see how we are going to see the mobile reports in your own mobiles. For now, I'll close this. Let's go on to the slides. I close that. So basically, this is what the vision is actually. So what you see on your left-hand side is like analyze and author. So you have your spreadsheets, Microsoft Excel, and you also have your Power BI reports. How many of you is using Power BI desktops? Power BI reports, okay, few of them. And you now have SQL Server Mobile Report Publisher, a brand new tool, which is a new one. And we also have the Paginated Reports where you use SQL Server Report Builder or Report Designer in SQL Server Data Tools. If you see the arrow marks, from Excel you can then publish to Power BI. You can go to that cloud and then you can use your Power BI desktop or mobile reports and report builder, designer, everything into your cloud. You also can publish these reports, Power BI, these mobile reports, paginated ones, some of them to go to your on-premises SQL Server reporting services. In your reporting services, you have an option of pin to Power BI, which means you build a report in your reporting services. When you pin it to Power BI, it creates a link to your Power BI local account. How does it happen? I go to view, full screen, and that. Oh, you don't see that. Sorry. So basically what I have done is I have opened Report Service Configuration Manager. Not you. In Report Server Configuration Manager, you have your regular options of your service account, database, and web portal URL. That's all basic. But now you have the last option called Power BI integration. With this, if you register this, as of now, I have my account, which I have integrated here, which means when I try to open up one of my reports, let's open my Paginated V1. Do you see a Power BI one? Pin to Power BI dashboard. So when you pin it, it's going to get into your Power BI, which means you can see that report in your Power BI itself. So we are trying to integrate everything into one. So that's what this slide actually says. So once you are done, you can render the report in your reporting services web portal, your SharePoint, or one set of mobile applications with Windows app or Android or iOS, and also Power BI web portal. Okay, so you can keep downloading Power BI in parallel while you're listening to these sessions. Let me go on to the next one. I also want to make it more interactive because obviously this is after lunch, so I have some information for you to say. I have this person and he's named Bob. Any Bob here? No, okay, so there's only one Bob then. He is a regular data geek like you and me. And he says like he wants to be a data scientist. How can he do that? And he's wishing to ask Genie to quickly learn him to get R, Hadoop, Python for his next interview. This is what he wants to do. And apparently, he's also a fan of Scarlett Johansson, so he's waiting to have a next movie release and he wants to see that movie. He guessed this and he wished it for Genie to do this. Then what happened was, ta-da, here it is. So meet Scarlett do Python. You did ask for Scarlett, Hadoop, and Python and R. So you got everything in there. Right, so it's just a like funny way of seeing things around. So at the end, I try to add R on it. So let's go into modeling and analytics. With modeling and analytics, the world is moving really, really very fast. What do we see with this modeling analytics is like, when we see things in general, we have plenty of different types of modeling. So statistical, econometric, scientific, predictive, graphical, and this is not just limited to these 5. There are loads and loads of them. For our example, in our sessions, we are going to do with predictive modeling. All I want to explain here is there are different types of modeling where it uses different types of learning, machine learning, different types of programs, different types of models, which come into the picture. Here, I want to show you a simple, quick information here, which has been done with predictive modeling and also the few other things, where this is a census taken based on month and what are the disease that happened to a patient. This is based in Columbia University from 1.7 million. So what they're trying to predict here is, you have the months here where you have winter, spring, summer, and fall. So all into 3 different months. So in here, you see if anyone born in January, he's likely to get hypertension. Anything closer to the month, most of the diseases here. If anyone going here, it's like most major disease. Okay, so here you have somebody's getting heart disease, angina. Anyone born in April? No, you're lucky. Okay, anyone in September? Asthma, November, ADHD, viral infection, plenty of different things that they talk about. I'm sure you're trying to see like which month you're born and you're trying to see what you're about to get, right? So, but this was true. This prediction was actually true, and they thought it could differ by patient, but it was the same for many years. And it does not also differ male and female. So obviously what they have seen is like for those who are born in January, we only see different variation between July and September. But apart from that, no matter whether you're male or female, you would still get that if you're born. So you're not born anything outside that time. Okay. I'm sorry if I'm trying to say like you're going to get that one. I'm not saying you're going to get it. It's like probably they're going to get it. It's a kind of prediction what they're trying to do there. As of now, if you go to Azure ML website from Microsoft Azure, these are the models, these are the process that you would get. See, here we have 4 different types. The first one is evaluate, second one is initialize model, then you have score, then you have train. So basically, you're trying to have some training data set to train a machine, and then you would test it whether the training data set works fine or not. Okay? So this has been separated into 4 different categories, as we see here. And it has to go through in a different process. As you can see in your initializing model, you have classification, clustering, regression, anomaly detection. This is not all of them what we got. Okay, so but these are the ones what we have as of now today. most of the models, I'm not saying like with this you can only do predictive modeling, but you would do a modeling, any modeling, but based on these sort of models. It's up to what your hypothesis is. It's up to what your company wants you to do, right? But you can't skip anything above to these ones. As you can see, from evaluate to initial model, then to score, then you train it. Then you would say like what is the proportion rate that you would really differ on it. Again, another gig that I want to see here. Does anyone know Madame Zaza? Definitely not. And she's none other than a fortune teller. She predicts what's going to happen in the future. She has got her own customers, and she keeps saying like what you have to do in your business, what you can't do like that. And apparently she lost her job because of we have so many number of machine learning, so many data scientists, so many data geeks like us. So we are all here and we are helping the companies so they don't go to Madame Zaza. Then she lost her job and she started learning predictive analytics. So end of the day, people are moving to a world where they want to learn predictive analytics and then the other worlds. Okay, let me dive deep into predictive analytics now. So as we see here, we have linear model, naive Bayes classifier, vector missions, regressions, neural network, boosted trees, forecast. So these are all like more towards into a modeling side where you would see these are the different types of things. I'm not saying these are the only things under predictive modeling. This is common for every single modeling, but it is up to you what you would choose. But in our example, for our life advanced things, what we're going to see is some linear model and forecast. We have no more, it is not a one full day of workshop, but obviously I'll try to cover as much as I can with these linear model and forecast side. And before we go into that, all I wanted to say you is predictive modeling, we have some rules and alerts, not just with that, but here we have some prediction problem because no model is better than the other. Sometimes when you choose a model, the other model would come out with nearby results, but the company would be happy with that one. So if you can't say this particular linear regression model will definitely give you a hand. Okay. If I really want to give one more example, with a regular linear regression, you can predict what's going to happen, like predict death, but you can't do on a time series based. You can't forecast it. You can forecast, but the results would be much better if you use another model like forecast. So these sort of things what we are trying to see, which one would be much better. And it makes more sense to use variety of different models to find the best fit. So you really have to think about it and you have to choose that one. Then we also have some inconsistencies. Inconsistencies means like it is not one company who built the product. It is an open source product. You start writing your own codes from some other models and packages, and you build your own package and you can upload to models. So you now have, as of now, 7,000 models that are available in our CRAN's website, which means like it's developed by different people. Obviously, it's been authored by so many people, like within our community itself. But end of the day, whatever is there, the syntax may be different with different models and different things. But this is what we need to understand before we go into that one. And as of now, like I said, many models are available in R itself. Okay, let's dive into see some Revolution R models in R Studio. How many of you worked with R Studio? 1, 2, 3, 2. Okay, let me close that. I'll keep that connected. Okay, that's much better. Okay, founding. So I'll give you a quick introduction about R itself so that you would know what R means. So I'm just trying to familiarize you with R Studio. R has got many packages on it by default when R is installed, but not all 7,000 models what is available on CRAN website is available right now for you, but you can install it on the go. But to see what are the models and packages that you got as of now, you can see installed packages, and you can see you all use your SQL Server Management Studio, right? So it works in a similar way, but if you have many windows, the result set is going to be a common one. You want to see what the result it look like for this window, you would still see the same one. So I ran this particular command, and I still see the same results pane. So you don't have to get confused with that one. And I also have Microsoft's RRE version, which was built on Visual Studio itself. But for some reasons, I like R Studio. That is because like the key combination, when I try to run the program, you have to hit your F5 or Control Enter on this one. It is much more easier here. Accidentally, though you selected only one line and you try to select run, I'll show you what I'm trying to say here. Things would go wrong at times. So with this, what I'm trying to say is, and when I hold on. So this is the command what I ran. So it shows us what command I ran, and these are the packages that we have. So color space, and this is the functions within that one. So you can see many coming through. Then it has got where exactly it is being installed, and so many other information. Now, if you want to play with R, you definitely need some data. You need data, so you can use either Excel, or you can connect your SQL Server, or you can build any other systems to connect to Oracle or anything else. But by default, this R Studio, like how it comes with R packages, it does come with some sort of data sets as well. In this example, we have chick WTS. I'm trying to run that, and you can see weight and feet, horse bean 179, and some sort of data is in there. To make you understand a meaningful one, air passengers. So this was one of the live scenario where it taken from 1949 until 1960. How many passengers flew? How many passengers were there during that time? So it is very easy for you to understand how we have a cross tab, and this data set is already available. Now, if you want to see what are the data is available, all you can do is easily simply use data open close and run. You get this window. With this, you can see what are the packages that are available here. Okay, here even you have Titanic, so you can see survival of passengers on the Titanic, and many data are available on these. And for example, diamonds is one of the one. If I try to run, it gives me an error message. That is because data, not every single function should work whenever you try to run it. It needs to require to bring the model first, the package itself. You need to require the packages to call it, only then it would work. The diamonds belong to a main package called ggplot2. So if I run that, which means ggplot is already installed. If it is not installed, all I have to do is install the packages and give the package name on it. So it's going to do it. Now when I say require ggplot2, it says it has loaded to the memory right now. Though it was installed, it was not part of that, and it says warning message, package ggplot2 was built under R version 3.2.5. Now if I run diamonds, there you go. Now you get the data set. Loads of them. So this is what you would see with the data. Now, before I go into this R Studio to learn more about linear models, I want to make you understand what it would take to you predict deaths from your own local laptop. How many of you got your laptop? You can open your laptop and then go to Excel. How many are trying? Just raise your hands. If you're trying, you can try just with very quick ones. It's not rocket science to it should be done with data scientists, but it is very easy for you to learn that one. So what I do here is so this is what the data I collected from my database, road accident table. So that's a simple command. What I've said is identify the total number of deaths per year. The accident severity is fatal. We have three different types of severity. One is fatal, one is severe, second one is minimal. So when it is fatal, which means it's dead. Based on that, I have just copy pasted this in this Excel. Make sense? Okay. Step one is that we got a data. Now I'm selecting that and trying to insert a scatter chart. That was quick. And now with the scatter chart, you can see, you understand this, how the process has happened. You can try this, and I simply right click on that, and I'm trying to add a trend line. And it adds a trend line based on that, and also it gives me options to choose what I need here. Here I have a display equation on chart, display R squared value on chart. So I simply click on this checkbox, right? When I clicked on that, I got this formulae. Y is equal to minus that number x plus b. So this is nothing but y is equal to mx plus b formulae. This is a simple linear regression formulae. Now how are we going to predict? So I am going to add a new column called predict. So y is the value that we are going to predict here, and m is minus 72.114 times, I am going to add, this is the death, right, and this was the year it started with. So I am going to say times that, then plus the number what it gave me, 146806. So it predicts 1928 people died with that based on the data trend line that it has drawn. So all I am going to do is simply drag and drop to see how many people are dead here with a simple linear regression model. Now we want to see how many died in 2015. What shall we do? 2015, bang, 1496 is been predicted based on the data what we have. 2016, this is MS Office 2016, so the formulas are very much quicker, and I see so many new changes being done as well. So 2017, 2018, but you can't predict data like with less than 5 years is like really not correct. So if you have at least 5 years worth of data, the prediction would be almost okay, but you can't predict just with what happened in last 6 months. Tell me what I'm going to do for the next 2 years. That's not possible. Okay, so it makes more sense now. Now, so this is step 1 of how would you identify a simple linear regression model to predict death. Now what I'm going to do is I'm again going to copy this, paste it here, and I'm going to use the data tab and choose data analysis toolkit. We also have the same things with the data analysis thing. So I'm going to choose data analysis. Sorry, I'm going to click it there, data analysis. Here I'm going to choose, there are so many models in here as well. Here I'm going to choose this regression. How many of you knew this data analysis pack was there? If it is not there, all you have to do is simply right click on that, customize this ribbon, and then you have to go to add-ins, or you go to file under Excel options, you go to add-ins there, and you have manage add-ins and click on go. Here you have these options. If you uncheck and say OK, that will disappear. If it is not there, you just check it here and click on OK, you would have it. Okay, so this is a simple add-on what you have. With that, I'm choosing that and clicking on the regression model and say OK. It gives us the regression formula. So input y range. So y I'm saying as that is the existing y, and input x range I'm saying that, and I'm going to say output range. So it choose for input output range, I'm going to choose that and say OK. I simply just drag and drop here. So basically what it has done is the data analysis tool pack have created a regression and statistics based on the data what you have fed for it, and you see the coefficient formulas that these two are the only thing that we need to worry about. So that what I'm going to do right now is I'm going to use the same formula. So for example here I'm going to say equals minus 72.1143 times for that year plus 146805.9. So it predicts the death as 1928.271. So I simply drag and drop and it calculates the value, and again for 2015 and 2016, let's try to compare this with that. Let's remove the last 2 years on that. If you see For 2015, 1495.59, and here we have 1496.29, almost nearby. So which means the prediction works. If you ask me to choose which one to choose, I would choose 1495.59 because that's the minimal one. We don't want more deaths, right? So this is basic things what we would understand. So we try to choose minimally what that would make sense. Do you understand how it works? Okay, it's a simple formula that you would get it from your Excel. Now if we pass the same data in our program R, what do I have there? So I'm saying year and dates. Instead of getting data from your Excel or instead of getting data from your SQL Server Management Studio itself, from that engine, you can clearly give your data here. So all I'm trying to do here is I'm combining all of these values into one simple column called year. Year is a variable what I'm trying to give here by myself. So I'm choosing the year dates and I'm choosing df year, and df year is another parameter where I'm saying put the data frame of year and month. So for example, if I do these two, it takes the command. I want to see what is in year. I simply run that. It says these are the values which we gave earlier. If I choose just dates and run, dates chooses that, and now we are going to combine these two together into df year. And now when I run just df year, the value looks like this. It's the same like how we looked into Excel. So you give some few formula in R and then you find it. LM is a function which is a linear model that is available within the R Studio itself. So I'm saying to find a linear model for df year. So df year is the last variable what we had. From that it chooses the dates. See here, if I say df year, it chooses the parameter, and when I say dollar d, no, shouldn't come here. It says these two are the columns that are available. So I'm saying dates, and then we are trying to predict it based on LM, and I'm trying to run how the LM would look like. So it says intercept 146805.89 and the df here is 72.11. You remember the same numbers what we got in Excel? It's almost the same. So the linear regression works throughout every single application the same. It is how we use it based on what kind of hypothesis what you have, what kind of requirements that you got. So you understand how this is working. And you can also do a mode prediction on this, like I'm trying to calculate here, combining them all together. I'm trying to get a final output of how this would work if I'm going to pass 2015 and 16. And I'm predicting the death based on the linear model again, and these are the 6 values. Now I'm putting them all into together as predict the results. Now you can see 2015 and 2016 values are generated. These scripts will be available, so you can play with it later on. We'll just try to cover the subjects. And this is not just the result what you want to see. If you want to see a very good results with the plot, you can simply put that into plot and you can see the same chart what that comes out with. So you zoom that up and then you see it. Okay, so that is that with the simple linear regression. If I go to the next one, here there is a function RODBC from a package called RODBC. I'm using that library and I'm giving a connection string SQL Server with that particular server which is my machine, and then I'm giving my road accident and my user ID and password, so my password, and we are going to create a connection. And see here I'm having a stored procedure called exit USB death human nature, which means programmability stored procedure USB death human nature. So what I have here is I have a concatenation and a union one to give a final output. I'll just try and run here to show how it looks. So here I have accident month, here I have total deaths human by month actually. What I'm trying to do is based on human error or by nature. I'm trying to join them all together. If I try and run this procedure, this is the output that I get. So, for this accident month 2009 January 1, total deaths by human is 138, because of nature it is 51. Okay. The concept what we have here is how many deaths we have and how many deaths we are going to have in future. So, this is the data set which I am trying to execute that. Instead of writing the SQL script directly, I am calling a stored procedure based on the connection what I have created. And I have a simple parameter to say to execute the SQL query using the my connection and the procedure what I am going to use it. So, I am going to execute that. And to see how the DHN looks like, so I simply click on run. There are so many values, I just want to see top 10 values or top 6 values. By default, when you give head, it runs only 6. So, here I can see, yes, these are the values that are expected. This is I am in the correct data set. Then I am trying to put that into a simple command here to say, starting from 2009 to 2015, frequency is like 12 months frequency, I have monthly data. I want to find the total deaths. So, I am trying to feed that there, and I am going to plot it. This is the output what we are seeing. I am going to use library forecast. Forecast comes into picture where you are trying to predict something based on a time series, year and month. So, forecast is the best model instead of choosing linear model. You still can do it, but it is like you have to have multiple linear plenty of things, but forecast is the best thing for as of thing what we are seeing right now. So, I am using that model. You can see that package is installed already. So, it is using that, and this forecast is only a package, but within that we have many models. One among them is TPATS, then we have ETS and also ARIMA. We are trying to use them here. I think I have gone down a bit. So, what I am doing is ARIMA H1 is the parameter what I am trying to choose here to put auto ARIMA based on the deaths human, and I am going to plot what I am trying to see in ARIMA. So, let me zoom that up. ARIMA have chosen that in 2015 and 16 this is the predicted death going to be, and you see a value lower value and higher value based on the data what we had in the past, and it predicts the blue color line saying this is the predicted death. This is from model ARIMA. Now, if we try and do the same with ARIMA, we did it, we did the plot. We are going to forecast that, and I have a very small window. I'm just trying to get it done. I also have ARIMA N1 and N2. So, there are a few parameters that I am running, and this is a function where if you want to see two windows in the same time, so this is what we would run, and I am predicting both of them together here. So, you can see these window showing two different systems. So, with just ARIMA model, we have predicted that these many deaths are going to be based on a human error, and these many number of deaths are going to be based on the nature. You see, from the human it is like almost constant, but with the nature it changes, right, because it predicts human beings or human beings end of the day they are going to be the same, right. This is the output what we are seeing in the using ARIMA model. Then I am trying to plot that to have a good visual to see only the prediction here. So, this is the zoomed up bit of what we saw earlier. Okay. Okay. So, we have seen some Revolution R models within the R Studio, and we have done some sort of prediction using a forecast package and models using ARIMA. All right. Now, let us try and jump into using the same model within our reporting services and to see how the reporting services would render a R script. So, I got this. functions, and then I've got so this is one of the procedures what I am creating, and in this procedure I am using sp execute external script, another procedure that comes out of the box from SQL 2016 onwards, and this is the parameter that you would pass where you are saying the language is R. In pretty soon you will be getting Python as well, and then you have this script where you are saying you are declaring some variables to say input dataset, image file should go into this particular location as accident line chart, and then we have this JPEG file with this size, width and height. Cross type data is a parameter again where we are trying to paste. You remember this script what we tried to use earlier, and then we are getting a plot cross tab data within the procedure what you are trying to call, and that is one of the parameter that you are passing for the script. So you wrote a T-SQL script which is simply an exec statement in program R. In Management Studio you are running R scripts using this particular stored procedure sp execute external script. So do you see the links between these two platforms now? And as an input you are giving this data to say what is in there. So I can't run that because I have double quotes on it. The system within R doesn't accept one single quote, so I am giving double quotes on that. Then I am going to use this particular model. And also I am trying to show you one more cool feature where this is again the same scripts what we wrote. So as of now we have many stored procedures which calls the same ARIMA functions and scripts within the procedure itself. Let me go into SSDT. SSDT now have been improvised a lot, where you don't have to install all your Visual Studios, all the local very heavy bits. We used to have these bits earlier. How many of you use bits and no more using bits? Yeah, so now we moved on. This is the Visual Studio package there. Great, it stopped working. Nice time. Let's try again. Not this time. Good, that screen is good. Okay, you see this Solution Explorer. So in here I have got the data source, one data source, and some few reports in here. I forgot to mention about the parameterized, customized parameter earlier in the report manager things. So the box what you see here, it looks like a table, but it is a table format where you would use your customized parameters on it. So for example, reward model, let me close them all and show you an example of how a customized parameter would work as a take this quick opportunity on that. So you can see I have a parameter here, report parameter. If I have to add one more parameter here, I simply right click and then say add parameter, and that's parameter 2. When I try to preview it, unfortunately with earlier versions you can't control which parameter goes to which place, but with this one now I can simply drag and drop where I want this particular thing to go to. So you can group them all into one place. So that's a quick example of how a customized parameter would work. Microsoft heard the problems what we faced earlier, so now that's been all fixed. One by one. If I don't want that particular model to look there, so all I have to do is go to port view and then uncheck the parameters, so that's gone. This is a quick report what I wrote earlier. Let me put this there. All I have here is a simple insert a table, okay, and then all I have done here is to insert, right click, insert, and then an image on it. So right click, insert row below. So I have 3 cells in here. I can right click insert. I've been searching the top. Okay, so the image what I want to insert. The image what I'm trying to see here is the image what has been produced by the systems itself. So I have built all the scripts in Management Studio as a stored procedure, and I've kept them all here as data sets. So I'll show you that. Here I have a model data set where I'm calling a stored procedure called RA history accident time frame. So there are a few models what I have like ARIMA, ETS, TBATS, all models all together. These are the stored procedures what I have built based on the R scripts. I have inserted the top image in these. So when I go to that image properties, I can see the field is actually coming from accident data and plot, and the size I am saying as original size. So if I have to do the same thing here again, I would say insert image, and I am saying instead of embedded I am saying it for database. I am saying accident data in plot. I am not using that. Size as original size and say OK. Okay, that is a JPEG what I have to give. Size OK. That is it. So I now have an image down. Okay. If I have to see the same image, you can see that in the preview bar how it would look like. So basically what this says here is you have deaths from 2009 until 2015, about 180 starting with and again ending with 180. The data output what you see here is rendered from R script, and it is the same image what you saw from R Studio. And I also have few other images where I have forecast of ARIMA where it has chosen those three models. Where's the other model that I have? The script what it is trying to say is like I have three different models, ARIMA, TBATS and ETS, and three models have shown the display. I don't understand why it's not showing up here now. Okay, let me open that. This is the published report what I have. And the variations what we see in ARIMA differs with other models as well. For that reason, we also have another procedures to choose. AIC is a matrix which would predict which model would be better compared to the others. So in here ARIMA is a better, and that's the reason why I've chosen only ARIMA instead of the other models. The minimal it performs, it is much better. And here I see from 2009 2015 as a whole bunch which I already again called earlier. I mean like I place the same image again twice here. Let me see if this is what I want to show you. The ARIMA, ETS and BATS, these three models, you see how it varies. You have a tick mark in BATS, you have a straight line in ETS, and you have variation line in ARIMA. Compared to these three, what would you choose? Right. Obviously ARIMA, that performs better compared to the other models. So this is a place where you would choose how it would look like. So this is one method where you would embed an image. That image calls a database, execute stored procedure, which that procedure again calls the R scripts. So R is connected to the image, and every time you run the report, it executes the stored procedure and it stores it. If I see where the images are stored, the images are stored in a place where I have given earlier as R output images. Okay. And these are all running on the go. I had this particular report to show you how we can utilize the new feature in SQL 2016 itself. So which I have again deployed it to the reporting services, saying new visualizations. Basically, we now have two new charts. One is a sunburst and we have tree map. So here I have two parameters to choose. In 2009 and 2010, tell me How many people dead just because of nature? This tree map is now showing us how many people are dead in 2009 and 2010. You see, like this particular one, raining, no high winds, is a major one. Because of rain and high winds, people are being dead. I'm not talking about anyone who are dead because of human error, but this is within nature itself, natural disasters. This does not make sense here unless we see it in this way, only for 1 year, and then you would see, obviously see only 1 year. But if you are trying to see for more than 1 year, the visualization is actually breaking. But tree map obviously makes us more makes it more useful for us to see how things would look like. And for that reason, I love this new map, which is the sunburst. All I have to do is right click, change chart type, and here I have this tree map and then sunburst. I click on that and say okay. Now I made the changes already, so I'm going to deploy this. Okay, that succeeded. I'm going to refresh the same report. Okay, function F11. Oh. So that makes more room for you to understand. Within 2009, from this month to this month, the problem was major to do with the raining only. You see, raining is taking half of the chart, half of the sunburst. If you see what happens when a human nature comes in, I mean human error, that half of the chart is gone, and 3/4 of the whole sunburst is occupied with just human error only. So we see the visualization better with the sunburst, right? And there are so many other sunburst things and tree map thing what you can use to predict plenty of things in differently. But 2016, these two are the very brand new one, and really makes more sense for many of the visualizations like what we have with the data. So then let's come into the mobile reporting side. With mobile report, obviously I couldn't do the do within my local virtual machine, so I have one more virtual machine. Cool. So in here I have the same data. You can see some of the accident reports and I have published online, and with these ones all I can see is like it again becomes more interactive. So for example, this one, accidents by condition. So it is again like on a mouse over you would have plenty of things based on what you would build and create. If you want to create the same thing by yourself, you would again do the same thing called new and mobile report, and then you would choose based on the data set what you have. So let me quickly open that. I'm going to choose a time chart, not time chart, total chart, and then I go to data. I say add data from the report server. So here we have some of the data sets what we have, and let's say with the speed limit, how many deaths occurred within this particular speed limit. So it's a different kind of visualizations what you really want to see there. Then here I say speed limit and with the total deaths, then I go back to layout, and you would see that's the total what it is showing, and by percentage. You would be tweaking that here and there. Now if you have the Power BI mobile, all you can do is you can simply go to this particular browser. Anyone having Power BI? No? I'll quickly show in my one. So basically I have logged in, and this is my Power BI. I gave my credentials. What you see on this screen, this is what you see here. So I have 2 KPIs in there, and I have 5 mobile reports. Okay, so I just choose any one, and there you go. So you have a mobile report that is coming from the live reporting system. So basically, I have enabled the DNS for the virtual machine, and I've connected the virtual machine DNS with the Power BI app. The Power BI app has got this new feature adding the reporting services thing, so that you can do it in your local mobile itself, on the go, wherever you are. Okay, that makes it much more easier for your mobile reporting. You can try this at home later on. It is much easier if you do the virtual machine, Azure virtual machine itself. That is the place where you can really play with adding the DNS. Otherwise, it would be not possible with the other ones. Okay, so we still have time. So I'm trying to cover up some more R here. Not too close. Okay.
Can I just ask you a question about
Yep.
R in SQL?
Yeah.
Why do you store the plots back into the English? Why not just store the data?
What I'm trying to understand is like you're asking why can't we have the data set within R and run?
Using R to generate data set, whatever model you want to apply.
Mm-hmm.
But then you're plotting that and then storing the plots and then displaying those plots.
Yes, plot is another package what we are trying to show the visualization only.
But I'm wondering why are you using R to do the plotting? Why aren't you using your visualization tool to do the plotting?
The R produces the base charts. R produces the modeling data, that outcome whatever we have. So we can see the R outcome within that. This is one method. What we are seeing is like to visualize that we are using already existing R charts rather than our own chart. Yeah. Okay, you don't have any feature as of now that using an R chart, using an SSRS chart, you can hook up that directly to an R model. You can only show that via an image.
Yeah, but you're running R inside a database.
You're again coming back to the same questions actually. So the way it works is like R stands and R engine is separate, and we have database engine separate. R accesses the Microsoft database engine to grab the data, do the modeling, and you're trying to see the visualization within reporting services instead of using R's plot. Yeah. Am I right?
Yes.
This is the question that you're asking. Again, to answer the same question, the report chart what you have in your SSRS that does not have a connection to speak to your R model, but you're having third-party tools where you have an R chart, like in Power BI you have embedded R. Similarly, the third-party tool, if you're trying to embed that in your reporting services as an additional add-on, you would be able to do that. With the current setup what we have, it is not possible. So you have to either use the image file where you render the image everything from the R itself, and then you see within the reporting services. As of now, we see the visualizations everything within reporting services, but backend it models everything using that one. And moreover, the charts and visualizations what we see in reporting services, we have seen many, and we only have brand new tree map and sunburster as of now. Previously we used to have very less chart, and at least now we have more, but we have unimaginable charts and visualizations from R itself. People like to use those visualizations rather than the reporting services itself, right? So I'll show you a quick example of how different visualizations would come out in R. So this is an example of using this particular SQL query what I'm using, and the data set looks like that. Again, how many months, in which year, on what month, how many people are dead. And here I'm trying to use a linear model, and if you see plot input, I'm using again a plot. If you see this visualization, this is much more different, and you can't have this visualization in your reporting services. So you would obviously use it. Yes, this is a three-dimensional picture of, you can't have everything in one picture. So here you see you have year, month, and total deaths. Do we have any reports, any charts in the reporting services to get this picture?
You're moving three dimensions into two dimensions, you just, all you're doing
No. What I meant is like, even when I was in the Hadoop Strata summit last week or 2 weeks ago, they were saying the same thing. So this is a three-dimensional picture what we are trying to see, the data itself, but not the visualization. Here you would see the same months, 2, 4, 6, 8, 10, 12, and also here how it would have looked in here. So I had this example to show you why it cannot work for this particular model, okay? But I'm only trying to show in a simple plot, a plot can have the different types of plot images that we can generate. But with simple one chart, by choosing in reporting services in SSDT, you can't have that. All you have here, sorry, it's already here. All you have here is what you see in here.
Just that you made a big thing about having a style, a look and feel at the start of SSRS.
Mm-hmm.
You can't really apply that back to R, so you're going to get whatever R gives you out, which is up to you.
The model statistic, I've only gave a simple example of with the live data, and what I'm trying to prove there here is like the reporting services tool can speak to our engine and then extract the model whatever the R generates, and the model, the plots, everything is modeled within the R. It is not done in reporting services. We are embedding that into the reporting services. That's how we are trying to generate the report output. And again, this example I was trying to have, like, you can only predict sometimes, for example, linear regression with numbers 1 to 12, something like that. But if you have, instead of 1 to 12, if you have January, February, March, April, it's letters, right? So it has to predict based on letters as well. So you have to feed the data to say like JAN, first 3 letters, and the first 3 letters every single month, and to say in that way. Here I had this example of this is the predicted model, and the base data looked like that. Earlier we had numbers, but here we have name of the month. Okay, so when I'm trying to predict here, if I say September and get me the new value out, and that's a new value, it comes out with 128.7905. Now if I change that value to August, it says 133.1238, which is good. Now instead of AUG, if I type AGU, it's a misspelling. The system did not accept it earlier. It still says 133.1238, which is wrong. There is no such month, right? So it is only saying what was the last predicted number, so it comes out with the same number on it. So for some reasons, these sort of things like linear models cannot be very straightforward to choose. You have to go with the actual models that are available, and then you can play with that. This is the forecast time. Again, I'm trying to go back to the same one. Here I have the same query. This particular R script is multiplied into 4 stored procedures, and that procedure has been run in the reporting services. In here, all I'm trying to do is to get the data, and I'm trying to put that into a cross tab. So which means the data, how it looks like this. Do you see this? This is in one simple, like 2 simple columns, accident month and total accidents, but you can use some other functions and models with cross-tab data with TS. TS stands for time series, and then it understands this is the year and month. You remember earlier we saw the flight accidents, air passengers, that how many people travel between 1949 to 1960. So it's a cross-tab data. So that is again a time series. So this helps us to see the visualization in a different way, and when we put that into plot, this is how it comes out. And as we tried earlier that we need to see two views, now I have to change it to one view so that I can better see it. See, that's gone here. And again, ggplot2 is the main one. It holds plenty of different sorts of visualizations. And I'm also using one more, which is the forecast. And ETS is the model what we saw earlier. And ETS1 and ETS2 are the two parameters what I'm trying to store. The model what it grabs data from cross-tab data itself. As long as you don't see any error message here, then you're good. Then when I run, this is the visualizations what we saw in SSRS itself. And again, this is the ARIMA. That's how it looks with ARIMA. And we are doing that with the third model, TBATS. When you see this button, it's running there. And this is the tick mark what we saw earlier in the reporting services itself. It's all simple scripts here what you see, and it can be easily embedded in the reporting services. Now we have three models from one single package, and we are trying to see all three together. But within RStudio, how you would see that? You don't see it properly. So you have to use this particular command to say, I want to see three images, three plots in one place. But what is par? Par is a simple another function. So within R, if you want to see anything more detail about the functions and scripts, you have to use question mark and par. It says like it's query graphical parameters, and on the graphic side how you would do the details and descriptions, and then some syntax. All informations are given here under help for question mark PAR what you have given. It's not just PAR, you can give anything what you want to know with a question mark on it. Now when I run them all together here I see them easily. So first one is ETS, second one is ARIMA, third one is BATS. Of these three, earlier within reporting services, we chose ARIMA. And we also had one more image to show which one performs better. So again, we are using the bar plot to combine the data set, what it has come out with. And this is the image what we saw earlier. Out of these three models, which AAC is minimal? The minimal object here we have is ARIMA. That's the main reason why we split every single data into different procedures. So what you see here, come on, not responding. So we have two simple parts here. Anything that you write in your stored procedure. One is to call input data set, which is coming from your database engine itself. So that is much easier. And the other one is the R script. So this R script uses the input data, and it is going to place the image on this particular location. Then you're making the cross-tab data, what we saw earlier, and you're putting the data set into a output image using the data set what you have provided. Then you are saying with result sets as accident data in plot var binary of max. So basically it stores a var binary object. So if I execute that, this is the output. Before we had this embedding into image file, we have seen this var binary max file. So if I see this location where it has stored the data in, Trevor models, output images, accident ETS. Those are the images that's been built based on the executing of your stored procedures. And I also have an option of running this using a PowerShell script. That's how we used to extract earlier. So I'm changing the location to my local one, and then I execute that script, edit, paste. Oh, sorry. Thank you. Set. Okay. So these are the simple commands that I passed to the PowerShell, and it's actually converting the var binary file into a image copy. So if I go to my E drive and then images, then you see, so it says 1 row is copied of RA forecast of deaths. And this gives us two simple views. One is by human error and nature for 2015 and 16 extension, and here it gives in brief of how the 2015 and 16 images are coming out with. Okay, we saw the demo. Thank you. If you have any questions, I can answer that. Just in case, as again, sleepy rides, if you can stretch, it'll be good, so that I have that line image on that one. So we'll try to include some sort of giggles here and there. Any questions?
Can we publish
Trying to publish a Power BI into SSRS. The SSRS reports what you have, you can pin it to your Power BI. Yeah. So when you pin it, when you go log into your Power BI dashboard, you can see a report what you have pinned there.
But we can't publish on-premise instead of database server.
No, it goes into two different things. You can only have option to pin. You remember the slide what I showed you earlier, how you will pin it to your local on-premises reporting services to the Power BI dashboard. Okay, thank you.